Today we want to talk about how to multiply polynomials. This is going to be somewhat in common with talking about how to add and subtract polynomials, as we're still going to be dealing with like terms, but before we look to combine like terms, we first are going to have to combine the two polynomials through whatever type of multiplication they're asking us to do. In general, you're pretty much going to be multiplying by either using the distributive property or FOIL method. FOIL method is for when you have two binomials. It's when you take first, outer, inner, last, right? That's what FOIL stands for. Really, FOIL is just a nice little acronym to help you remember distributive property anyways, so you really could just say you're always using distributive property. But anyways, what you're going to use however you know how to multiply, and then once you've multiplied, you will look to see if you can combine any like terms. For example, let's say I asked you to simply take the polynomial 3x minus 2 times the polynomial 3x plus 2. Well, this is a binomial times a binomial, so we could choose to do this by FOIL. If you understand FOIL, feel free to do it that way. If you don't know FOIL, then I don't really think there's a reason to be reteaching it to you at this point. We can just look at it as distributive property. In this case, it would effectively be double distributive property because we're going to need to distribute twice. Meaning from the first polynomial, I'm going to take 3x, just 3x, and I'm going to distribute that into the second parentheses. 3x times 3x. Well, 3 times 3 is 9. X times x would be x squared. So we have 9x squared. Then I would take the 3x and distribute it to 2. 3x times 2, 3 times 2 is 6. The x basically is just along for the ride because we don't have another x to multiply it to. Now that I've distributed that 3x, I'm done with that. I can pretty much ignore it for the rest of this problem. I'm going to move on to the second term in my first parentheses, my first polynomial, of negative 2. We'll use a different color for that just to be clear. So now I'm going to distribute that negative 2. Negative 2 times 3x. Negative 2 times 3 would be negative 6. And again, the x is pretty much just along for the ride because it doesn't have any other variables to multiply to. It doesn't have any other x's to multiply to. Then we're going to take negative 2 and distribute that to positive 2. Negative 2 times positive 2. Remember, a negative times a positive is a negative. And 2 times 2 would give us 4. That is all you have to do as far as the multiplying part of this. Now, this is not necessarily our final answer, because for this to be our final answer, we need to look at what we have and see if there's any like terms that we could combine. Well, when I go looking through here, the first term I see is 9x squared. So remember, when we talk about like terms, not only do the variables need to be alike, but they have to be the exact same exponent. So when we have a 9x squared, the only like terms I could combine that with are any terms that have exactly x squared. I don't see any other x squared terms here. So I have nothing to combine it with, which means I just rewrite the 9x squared as part of my final answer. Moving on, the next term that I see is a 6x. Just one single x, x to the first power. So if there's any other terms that also have just an x to the first power, those would be like terms that I could combine. For example, this negative 6x right here. It also is just x to the first power. Those are like terms. When we have like terms, remember the way we combine them is we want to combine the coefficients, the numbers in front of the variable. So positive 6 minus 6, or positive 6 plus a negative 6, would cancel out to simply 0. So we have a 0x. Well, if we think about that, when we say 0x, what we really mean is 0 times x, and 0 times anything is just 0. So when we say it cancels out, it really does just cancel out. You don't have to write that 0x there if you don't want to. It's not really there. It's essentially non-existent. Up to you if you want to take an extra step to show that or not. Finally, I see a negative 4 sitting here. That is a constant. It has no variables with it. So I look to see if there are any other constants, and certainly there are not because negative 4 is already the last term, so I don't have anything else that I haven't touched yet. So I just rewrite negative 4. Just rewrite negative 4, and that would be our final answer here. That's how you would multiply those two polynomials. Let's do another example. Concept is going to stay the same, it's just going to be a little bit more involved of an example, just a little bit longer of a problem. So let's say I give you x plus 2 for your first polynomial. But let's say for our second polynomial, I give you 5x squared plus 3x minus 1. It's still a distributive property here. Now the problem would be if you did FOIL for the first example. If you did the first example using FOIL, well technically FOIL doesn't work here because first, outer, inner, last wouldn't cover everything in this problem. You really need to look at this problem specifically as a double distributive property. Because what we're going to need to do is we're going to need to take x and distribute that to all three terms in the second parentheses. And then we're also going to need to take positive 2 and distribute that to all three terms in the parentheses. So let's do that. We'll start with x. X times 5x squared. Well, remember, if it's just x, that's really 1x, right? If they don't show you a number in front of a variable, there's always a 1 there if nothing else. 1 times 5 is 5. X times x squared would be x to the third. Right? Remember, x squared is the same thing as x times x. So if we're taking x times x squared, we're effectively taking x times x. And if you're multiplying three x's together, we show that as an x to the third. Right? That's what we're doing there. Then we want to take 1x and distribute it to 3x. 1 times 3 is 3. X times x would be x squared. Then we'll take 1x times negative 1. 1 times negative 1 would be a negative 1 because a positive times a negative is a negative. And we also have the x as well. So negative 1x, or you could just write negative x if you want to, because remember, you don't have to show that 1. It's up to you. Now that we've distributed the x entirely, we move on to the second term in our first parentheses, our first polynomial. We're going to take that positive 2 and distribute that to all three terms in the second parentheses, the second polynomial. Positive 2 times 5x squared, well 2 times 5 is 10, so we'd have 10x squared. Positive 2 times 3x, 2 times 3 is 6, so we would have 6x. And finally, 2 times negative 1, a positive times a negative is a negative, and 2 times 1 is 2. That's all of our multiplication for this problem. Again though, this is not our final answer, because we still have to take the second step of combining any like terms we may have. To begin with, I see a 5x to the third. Remember, for it to be a like term, there would have to be another x to the third, and there is none. So 5x to the third has no like terms to combine with. We will simply rewrite it. Then I have a 3x squared. Well, I do have another x squared term over here in 10x squared. 3 plus 10 is 13, so we can combine those into a 13x squared. Likewise, we have a negative 1x, or a negative x, and a positive 6x. Negative 1 plus 6 would give us a positive 5x. Finally, we've got a negative 2 over here. It's our last term. It's a constant. I don't see any other constants in this problem, so we just have to rewrite it. And that would be your final answer for multiplying those two polynomials. Last example I want to show you real quick is what happens if you are given three polynomials to multiply together. For example, let's say I asked you to take x minus 2 times x minus 1 times x plus 3. The short version is you cannot multiply these three together simultaneously. You need to take them two at a time, meaning you need to pick two of these, multiply those two together, and then you can multiply the third one in after. For example, let's say we decide to work from left to right, because that would make sense. So we're going to look at just these first two polynomials, just x minus 2 and x minus 1. Let's multiply those two together. So whether you do this as foiling or double distributive property, we'd take x times x to give us x squared, x times negative 1 to give us negative x, negative 2 times x to give us negative 2x, and negative 2 times negative 1 to give us a positive 2. We will still need to eventually multiply that by x plus 3, so I'm going to keep rewriting it even though I'm not using it yet. I think it'd be best to go ahead and clean up what we have in the first parentheses and combine our two like terms here to make this x squared minus 3x plus 2. Minus 3x, because remember this is a negative 1x, and negative 1 minus 2 would be a negative 3. Now that we have fully multiplied the first two together, we can go ahead and take that answer we got and multiply it to our third polynomial, our third quantity. So, kind of a triple distributive property here. X squared times x is x to the third. X squared times 3 would give us 3x squared. Then we go to negative 3x and distribute that, so negative 3x times x would be negative 3x squared, and negative 3x times 3 would be negative 9x. And then finally we distribute the 2. 2 times x is 2x. 2 times 3 is 6. Now we've done all the multiplication, we can finally go ahead and combine our like terms and be done with this question. I see an x to the third term. I don't see any other x to the thirds, so I will rewrite that. We have a positive 3x squared and a negative 3x squared. Just like in the other example, those would cancel out to 0. We have a negative 9x as well as a positive 2x. Negative 9 plus 2 would be a negative 7x. It's kind of a bad 7 there. That was not much better. Apparently I can't draw 7s very well. And then finally, we have a constant of 6. Constant meaning it has no variables with it. I see no other like terms, so I just rewrite it. That would be our final answer for this problem.